Hi, Mr. Schmidt.
Hi, Mrs. Schmidt.
Wow, so today we are going to be working on NBT.2. What is NBT.2? Well, my goodness. You know, there is that big standard there, but I really don't want to do all of that, Mr. Schmidt. I want to make it so it's easy for the kiddos to understand.
Yeah.
So the first one says, I can use whole number exponents to show powers of 10. Well, what does that mean, Mr. Schmidt?
Exactly. We need to make sure everyone knows what an exponent is, what a whole number is. Okay. So I'll read the definition for exponent.
Thank you.
It says, in a power, the number of times the base is used as a factor. In 5 to the third power, the exponent is 3. So this little number up here, called a superscript because it's lifted up there and it's smaller, that's the exponent in this number. And if let's just write that out real quick. That would actually equal 5, right? That's the base. Here's the base. As in here, over here, 10 is the base. But in this one, 5 is the base, and the exponent's 3. That means you have 3 factors, and all of them are 5s. And you would multiply those out.
So, Mr. Schmidt, I know some kiddos, they look at that and they say, oh, that means 5 times 3. But that's not what it means, is it?
No, if it was 5 times 3, we would just write 5 times 3.
Yeah, this means 5 times 5 times 5.
Right.
Yeah, and the model that we have over here, 10 to the 9th power, the exponent 9, means 10 times 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 10.
We can show them down below.
That is a lot.
We have a chart, and I think that one's on it.
Okay.
Okay,
so
want to tell them what a power of 10 is?
A power of 10. A number like 10, 100, 1,000, and so on, it is the result of using only 10 as a factor.
Right.
Okay? So, 10 to which power?
So before we even show them the chart, let's look at, you guys, if you've used base 10 blocks, you've already played around or manipulated powers of 10. This is 10 to the 0 power. Any number to the 0 power is 1. And if you want to find out why, you can Google that and find out why.
Well, Mr. Schmidt, I look at that and say 10 to the 0 power. Well, my goodness, that means it's nothing? No, it means that it is not a 10.
Right.
It's not a 10.
It's any number raised, they call it raising it to the power, raised to the 0 power is just 1. And there's an algebraic reason why that works. And I thought it was interesting. But anyway, that's for when you guys get more advanced.
I'm really happy that you tossed that in there because,
So 10 to the first power, that's 110, right?
Yeah,
we don't multiply it times anything. It's just 110 as a factor, but nothing else. So that's 10 of these blocks, and that's a rod.
Yeah.
And then 10 to the second power is 10 times 10. Let me show you on the chart here. 10 to the second power, or 10 squared. Sometimes they'll call it 10 squared.
Yeah.
10 times 10. And so you have 100. And that's because there's 10 across the top, 10 down the side. And if you multiply those two, you would get 100.
Yeah, and you remember, Mr. Schmidt, 10 times 10 means there's 10 tens.
Yes.
So if I look at that flat, I can see for myself that I have 10 of those rods on that flat.
Exactly.
So that's cool.
And then, if you look at this block, we're multiplying by 10. Again, 10 to the third power, or 10 cubed, sometimes they call it, is 3 factors of 10. So it's 10 times 10 times 10, and that would equal 1,000 here. It would be like if you stacked up 10 of these flats.
Absolutely.
Or 100 of these rods.
Yes, yes.
And you would have 1,000 little unit cubes in the block.
Yeah. There. I can see that. I can see. If you go back up to that again, Mr. Schmidt, I can see that I'm not going to write on it, but I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of these flats there. So if I'm looking, I've got 1, then it got 10 times larger. And then I look again, it got 10 times larger. Then I look again, it got 10 times larger.
Yeah.
That is pretty cool, Mr. Schmidt.
And you guys can notice a pattern here in the base 10 blocks and in the chart. When you see 10 to the 0 power, how many zeros are in the value here? None.
None. No
Zero.
zeros.
There are 0 zeros in this number. How many zeros are in 110? Just one.
Mm-hmm.
How many are in 100? 2 zeros. The exponent is 2 and there are 2 zeros. So that's a pattern. And it follows all the way down this chart. We had 10 to the 9th power up here, right?
Yeah.
So let's look at that. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 tens. And if you multiplied all of those, you would collect all these zeros and put them behind this 1. And so do we have 9 zeros? We have 3,
yes,
and 3 more,
we
and 3 more.
do. And one thing I want to point out with all of my major years of teaching and gray hair, Mr. Schmidt, I remember I had lots of little kiddos that made the mistake of saying, well, I need to put down 9 zeros, but then I need to add this one too. We don't need to do that, do we?
Nope.
No. So we put down, in this case, we're doing powers of 10, which is a 1. And how many zeros? 9 of them.
Yes.
We're not going to say, well, 9 plus 1 more. No, 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 no. It would be 1 plus 9 zeros.
Right.
Okay.
Okay. So now we're on to the next step. I can explain patterns of zeros in a product when multiplying a number by powers of 10.
Yeah.
So remember, powers of 10
Mm-hmm.
equal these different amounts.
So we have our powers, our
Right.
expression, and then our standard form,
Right.
what it looks like to us.
So this is
Okay.
a power of 10. This is
Yeah.
10 to the 1st power. This is 10 to the 7th power.
Mm-hmm.
Okay.
Yeah.
Okay.
Okay, so again, it says I can explain patterns of zeros in a product when multiplying a number by the powers of 10. So we put up a couple of them, and let's see if I still have my my pretty perfect tools up here. Okay, I'm gonna use this pretty. It looks kind of like magenta. So I have 5 times 10. Well, that is 5 ones, correct, Mr. Schmidt?
Yes.
Okay, so
Wait. 5 times 10? What are you writing?
yeah, I have 5 ones, and I'm going to multiply that by 10, correct?
Oh, okay. I see. You're
So I have 5 ones, and I'm going to multiply that by 10. So if I multiply, I'm going to get larger, and so I'm going to, and each place is going to be, so it's going to be 50, correct?
Mhm.
Or if I think about that, and I know I'm jumping ahead, but 5 times 10, so I have 5 times 10, which is going to be 5 times 1, and then add the 0. I have 50,
Mhm.
okay? On the other hand, I have 5 ones, and I'm going to multiply that by 100. And I like to just jump ahead. So I know that's going to be over here times 100, which is going to be in the hundredths column. So it is 5 hundredths. Correct?
Yes. Ooh, that 100 looks kind of bad, though.
It kind of looks bad. Okay, I apologize.
Okay. So yeah, I just wanted to point out that one thing that I do in my head, let's say if we had 6 times 1,000. And I know most of you, oops, mine looks bad too. 2, 3.
I wasn't going to say anything.
6 times 1,000. What fell on the ground? Okay. So 6 times 1,000. You know, guys, I see these 3 zeros and I would write that down right away. Okay, I've got 3 zeros. And now what do I have left? 6 times 1. What is 6 times 1? 6. So that's another way to do it. Just quick in your head.
Yeah.
Okay, so
Very
that's the
good.
pattern.
Mm-hmm.
Count the zeros, put them at the end, and then
Yep.
do your multiplication.
Absolutely.
Okay.
Okay.
I can explain patterns of decimal placement when a decimal is multiplied or divided by a power of 10. So this means we're going to have to do 2 problems. It says multiplying times 10, you move the digits left 1 space.
Mm-hmm.
If you divide by 10, then you move them right 1 space. So
Okay.
why is that, Mrs. Schmidt? Why do you move the decimal to the left? Oh,
Well-
no, the digits move. The decimal doesn't. The decimal
Yeah,
actually
the
is moving the
decimal
other
never
direction.
Moves.
Yeah,
Yeah, the
yeah.
decimal never moves. I like to tell kiddos, the
Right.
decimal never moves. but we shift our digits.
Right. And that's what this chart's all
yeah.
about. So let's show them a couple of them.
Okay, so I think about that, and the very first thing I want to do is I'm going to come up here to the top, and I'm going to say, I like to do this here. I like to say, I am going to go this way when I multiply. Okay? Because when I multiply, I think about my bank account. When I add money to my checking account, I'm going to get more money. Now, these are a fraction of, let's say, $1. This is $1. Now I'm increasing my dollars. So let's say that I have $4, and I'm going to multiply. I'm going to put in 4 times 100. Correct? So I'm going to come over here, and I'm going to say, well, I started out with $4, and then 4 times 100. So that means that I've gotten. So this is going to be 10. This is going to be 100. So I'm going to move my 4 right there. And now I have $400. And if you will pay attention right there, Mr. Schmidt, how many zeros do I have?
2 zeros.
2 zeros right there. So I added my 2 zeros and I shifted my 4 over to there.
Okay.
400.
Let's make it a little more complicated though, because this looks a lot like the patterns of zeros. Let's make it harder for them.
Okay.
So let me see. I'll leave your multiplication moves shifts to the left. Okay. So let's say we have 365 and 1/4, which is 25/100. Okay. So what if I multiplied that times 4? Because I want to know how many days are in 4 years. So this is a year, right? 365 and a quarter days times 4. Would you show me how to do that?
Well, times 4.
Oh, wait. Times powers of 10, right?
Yes.
Are we? Yeah, dividing and by 1,000. So let's say we multiply this times not 4. Let's use 100.
All right. So if I was
I got carried away. I was trying to do advanced.
Mr. Schmidt was getting all crazy talk with me. Woo! He'll pay for that. Okay. So by 100. Well, my zeros right here, guys. Let's do Mrs. Schmidt's way. You know, she likes to cheat and take shortcuts. Times 100. So that means 2 zeros. She's going to shift it 2 times. It got 100 times larger. So if I come down here, this is 1, which is where we are. 1, 10, 100. So my 3 is going to move over here. Okay. Then my 6 went down to 1, 10, 100. So it's going to go there. And my 5, 1, 10, 100. And then my decimal, guys, remember what I said. It never moves. 2, which is 1, 10, 100. And then my 5, which is going to be 1, 10, 100. So now my new number is going to be, let's see, 36,525.
Cool.
Very good.
Cool. So, guys,
so Mr. Schmidt made something hard, and we made it easy.
These 2 zeros mean you have to shift, right? You're multiplying, so you shift to the left, shift the numbers 2 spaces, right?
Absolutely.
2 columns.
Yes.
Okay, cool.
All
Let's
right.
do a division problem now. Show them what to do for that.
Okay, so Mr. Schmidt wants to get all ugly with us, so let's just start that way. So let's say that we have so we have 14,000. Oh no, I'm sorry. Oh,
I'm not the only one.
Oh, Mr. Schmidt. Oh, how could you let this happen? So I have 1,432 and 15 hundredths. Okay, so I'm going to put down where, see, I can use my chart right here. 1,432 and 15 hundredths. And I'm going to go ahead and I'm going to multiply that.
Wait. We have to do division now.
Oh, yeah. Mr. Schmidt. Yeah. Thank you. Okay, so I'm going to divide. All right.
So guys,
I like
are we going to
that.
move the same direction this time?
No.
What's multiplication versus division? They're opposite of each other.
We're gonna divide by 100. So divide means ooh, I lost some cash.
Shift everything to the
So
right.
I'm going to divide, which means it's in smaller portions. Okay. So again, if I'm going to divide by 100, how many times am I shifting, folks?
There's 2 zeros. That means 2 columns.
So I come down, and that's the same place. I'm going to go 1, 2. So I'm going to put my 1 there. I'm going to come down. I'm going to go 1, 2. It's going to go there. My 3. It's going to come down. 1, 2. We skip over that decimal, just like it's not there. It's a speed bump. Come down, and I'm going to go 1, 2. Then I'm going to come down. I'm going to go down and go 1, 2. And so my 1's going to go there. I'm going to come down. I'm going to go 1, 2. And there it is.
Yeah.
So what is my new number? If I've taken 1,432 and 1500ths, divided it by 100, now I have 14 and 3,215 10,000ths. Okay? There you go.
Awesome. Okay, guys. That concludes our video today.
Smack! We did it, guys!
Thank you
Easy
for watching.
cheesy. Can't believe how easy.
Thank you for watching, guys. Bye.
Bye.